Okay, this is part 181. Line 18A, 3z5b5 Coulomb barrier, nuclear, bisphere, fiber laser, light resonators, 5G Wow Seti. There's the radio signal there. So I googled the word Coulomb barrier to find out what it means, okay? It came up in the last few videos, and this is the one where I define it, and then I looked into it a little more further to see what we can do with it, okay? So the Coulomb barrier, named after Coulomb's law, which is named after physicist Charles Augustin de Coulomb from 1736 to 1806, is the energy barrier due to electrostatic interaction that two nuclei need to overcome so they can get close enough to undergo a nuclear reaction. This energy barrier is given by electrostatic potential energy, and there's the readings for it, or sorry, the formula for it, okay? So we got K is the Coulomb's constant, EO is the permittivity of free space, Q1, Q2 are the charges of the interacting particles, and R is the interaction radius. So take a look at that there, okay? A positive value of U is due to a repulsive force, so interacting particles are at higher energy levels as they get closer. A negative potential energy indicates a bound state due to an attractive force. Coulomb's barrier increases with the atomic numbers, i.e. the number of protons of the colliding nuclei. And there's the fractions there, where E is the elementary charge of this, and Zi the corresponding atomic numbers. To overcome this barrier, nuclei have to collide at high velocities, so their kinetic energies drive them close enough for the strong interaction to take place and bind them together. According to the kinetic theory of gases, the temperature of a gas is just a measure of the average kinetic energy of the particles in that gas. For normal gases, and the Maxwell-Boltzmann distribution gives the fraction of particles moving at a given velocity as a function of gas temperature, and thus the fraction of particles moving at velocities high enough to overcome the Coulomb's barrier can be derived. In practice, temperatures needed to overcome Coulomb's barrier turn out to be smaller than expected due to quantum mechanical tunneling as established by Gamow. The consideration of barrier penetration through tunneling and the speed distribution give rise to a limited range of conditions where the fusion can take place, known as the Gamow window. It was the absence of a Coulomb barrier for the neutron that enabled James Chadwick to discover it. And that's from Wikipedia under Coulomb barrier. So April 6, 2012 is when I wrote the notes on this particular thought. So it's my thoughts. Alien formula had an E and a Z in it. I don't know if you've seen those videos. They're in line 17. T2B, I believe. There's about 4 of them where there's an actual alien formula written down. I don't know what it means, and these videos with the data are actually bringing up the meanings of those formulas, so that's kind of cool. But when I say alien formula, it's like alien to me, and I googled it and no one has a formula like it online, so it's from some other source. So alien formula had an E and a Z in it. I thought it was Euler's number and Z bosons. So that's what I think it is earlier in these videos. We're in the 180s now. I've done up to 180 videos about this, so of course, like I said, things are going to change, fractions will change, ideas will change as we learn more and more, okay? I wonder if it's this instead, E for elementary charge, which is that number there. So Z1, the corresponding atomic numbers. This stands out. Coulomb's barrier increases with the atomic numbers, i.e. the number of protons of the colliding nuclei, which is that there. To overcome this barrier, nuclei have to collide at high velocities so their kinetic energies drive them close enough for the strong interactions to take place and bind them together. To the kinetic theory of gases, the temperature of a gas is just a measure of the average kinetic energy of the particles in that gas. And the reason I'm replaying it over again for you is to show you what thought I looked at and what it means to me, or what I can pull from it. I pull data from the data I read. My thoughts continued. Kinetic theory of gases. If we change the temperature of the liquid argon gas, will it allow us to measure the energy of the neutrino particles in that gas should they be coated with something like mineral baby oil, causing them to sparkle after colliding at a high velocity? A strong interaction would mean the neutrinos have to be escalated before leaving from one side of the beam. Coated with the baby mineral oil, you want to mix them with the nuclear reaction using liquid argon gas, and then add the formula for split leptons and collide them in a mixture in the middle. Since neutrinos mimic other particles, which one can we convert from liquid to gas to solid within a short period of time, allowing it to manifest enough staying power to create the type of nuclear reaction you require? So I'm going to Google MKT neutrinos. Italy's National Institute of Nuclear Physics, INFN, said on Friday that Antonio Erudito had stepped down as coordinator of the so-called opera experiment. This is what came up when I Googled that word, okay? So that's from Reuters.com. So April 6, 2012. I read this and want him to know, this is a message for Antonio. There's a reason he's left. He will be doing bigger and better things in the future with the knowledge he has and the right tools. He will find what he's looking for. That's what came to me when I read it. So you can give him that message. April 6, 2012, my thoughts. I always find the most interesting things when I do this. Keywords, inventions, and patents found while doing research. First keyword was quantum tunneling. Exponentially decaying electromagnetic field was the next one. And that was under evanescent wave coupling. So, and then this is the PDF file that comes up. Increasing the enhancement of SIRS with dielectric microsphere. From www.bme.umich.edu. It says, from I Am White, 2006. We show an additional system gain of more than 2 orders of magnitude to SIRS, SERS, by using a dielectric microsphere resonator to capture and excite the target. So that's a Google thing that came up. The next thing that comes up is surface enhanced Raman spectroscopy, or surface enhanced Raman scattering, SERS. So optical fiber taper coupled glass microsphere resonators. This comes up next. Citation is from Kai Ming, 2001. Okay, so that's from resolver.caltech.edu. And his abstract says, it's a thesis, okay, so it's a theory. This thesis studies optical fiber tape coupled dielectric microsphere resonators and their applications. Fundamental properties including ideal coupling and critical coupling in an optical fiber taper to fuse silica glass microsphere coupling system is investigated both theoretically and experimentally. So I guess he has done some experiments here. A symmetrical dual taper coupling configuration is proposed to obtain highly efficient power transfer. Oh, there we go. We have some power transfer there. We need power, right? From the taper coupler to the microsphere resonator. I have absolutely no idea what these things are. You guys do. So hopefully you can use them for what we're looking for. Applications as channel add drop filters and microsphere lasers are also demonstrated. The physical essence of the fiber taper to silica microsphere is analyzed using a two-dimensional model. The relationship between the coupling strength and the cavity loss is unveiled. Adiabatic tapers and high-quality microspheres are fabricated and used to demonstrate actual coupling systems. Perfect agreement between the experimental results and the theoretical prediction is presented. Power transfer from the taper to a microsphere resonator has been significantly improved by employing a dual taper symmetrically coupling configuration up to -28 dB. Extinction at the central resonant wavelength has been measured. We then propose a device application of the taper sphere taper structure as a channel add drop filter in the wavelength division multiplexing systems. For a filter with a bandwidth of 3.8 GHz and a dropping channel isolation of 26 dB, the bit error rate measurement shows no power penalty at 2.5 Gbps. per second, per S. I'm assuming that's per second. A 1.5 wavelength signal frequency fiber laser is also demonstrated using a single tapered fiber coupling to a highly doped ytterbium barium phosphate glass microsphere. The fiber taper serves the dual purpose of transporting optical pump power into the sphere and extracting the resulting laser emission. As low as 60 UW pump threshold in fiber coupled output power as high as 3 UW with single mode operations are obtained. Imaging of photoluminescence from the sphere at visible wavelengths reveals the pump power is resonantly coupled into semi-classical orbits due to the strong absorption damping in the phosphate glass. A bisphere laser system consisting of 2 microspheres attached to a single fiber taper is also demonstrated. Finally, a novel hybrid fiber taper made from a combination of 980 nm single mode fiber and a 1550 nm single mode fiber is proposed and demonstrated as the microsphere, I don't know if it's microsphere laser coupler. Maybe they got their words mixed there. Both the pump wave and laser emission are found to be more efficiently coupled to and from, respectively, the sphere modes. As high as 112 UW, single frequency laser output power is measured with a differential quantum efficiency of 12%. So it's a PhD, electrical engineering, Caltech community. This is thesis.library.caltech.edu. So tapered fiber bundles for coupling light into the in out of cladding pumps. David John Giovanni. This is an invention that came up, patent number 5864644, and it was filed in 1997 and issued in 1999. So this is the tapered fiber bundles for coupling light into and out of cladding pumped. This is his patented invention that came up from the Wow signal. There's the information, the abstract. In accordance with the invention, light is coupled from a plurality of semiconductor emitters to a cladding pumped fiber via tapered fiber bundles, fusion splice to the cladding pumped fiber. Individual semiconductor broad stripe emitters can be coupled to individual multimode fibers. The individual fibers can be bundled together in a close pack formation, heated to melting temperature, drawn into a taper, and then fusion spliced to the cladding pumped fiber. Advantageously, the taper is then overcoated with cladding material such as low index polymer. In addition, a fiber containing a single mode core can be included in the fiber bundle. This single mode core can be used to couple light in or out of the single mode core of the cladding pumped fiber. And I'm sure you know what that means. I don't. Okay, April 6, 2012. Again, I'm videotaping my research. That's all I'm doing. It's up to you guys to figure out what you can do with this stuff. Okay, so I'm going to Google a bisphere laser system from theory. So up comes the optical fiber taper coupled glass microsphere resonators from Kai Ming, 2001. My thoughts. This came up right away. Fiber coupled microsphere laser. Okay. This is from Kai M, Painter O, Valhalla KJ, and Sershel PC. And it looks from October 2000. So it's fiber coupled microsphere laser. We demonstrated a 1.5 micron wavelength fiber laser formed by placement of glass microsphere resonators along a fiber taper. The fiber taper serves the dual purpose of transporting optical pump power into the spheres and extracting the resulting laser emission. A highly doped ytterbium phosphate glass was used to form microsphere resonant cavities with large gain at 1.5 micron. Laser threshold pump powers of 60 MUV and fiber coupled output powers as high as 3 MUW and 60 MUW with single mode operation were obtained. A bi-sphere laser system consisting of 2 microspheres attached to a single fiber taper is also demonstrated. And that's PMID is 180662238, and that's at www.ncbi.nlm.nih.gov. April 8, 2012. Google this, kinetic theory of gases. Keyword. According to the kinetic theory of gases, the temperature of a gas is just a measure of the average kinetic energy of the particles in that gas. Again, here's the other videos. There's 8 of them all together, talking about the same things, and we break it down into 8 videos so that they aren't too long. Well, 15 minutes is long, but if I would have done them all together, you would have had at least 3 hours worth. Okay, so we'll go on to the next video now.